In this video, I will be discussing mass wasting mechanisms. The term mass wasting is one that many people are unfamiliar with. However, the individual examples or mechanisms of mass wasting are very well known and can have a direct impact on our lives. What is mass wasting? At first, you may think that this refers to the amount of food wasted at the dining halls, but instead, it is the downslope movement of material under the direct influence of gravity. If you have ever watched closely at the way that sand piles up at the bottom of an hourglass, you may have noticed that every few seconds some of the sand slides downslope when the pile grows too steep. This is essentially mass wasting, the pull of material downslope by the influence of gravity. Factors that influence mass wasting: slope stability and the angle of repose. The angle of repose is the maximum angle the material will hold without failure. It is influenced by the material that makes up the slope. For example, unconsolidated sand is unable to hold the same angle of repose as solid bedrock. For this reason, you do not see cliffs made up of unconsolidated sand, but instead of solid bedrock. Vegetation can help to hold the soil in place, and therefore resist the effects of mass wasting. Climate and water content can have a major impact on mass wasting. Let's think about an arid environment that lacks vegetation. If this environment is suddenly exposed to a great amount of water, the soil can oftentimes become saturated and begin to flow. This concept will be discussed in further detail later in the video. External factors, such as earthquakes, volcanoes, and oversteepening of slopes, also influence mass wasting. Types of mass wasting. There is fall, which involves material free falling to the ground. Slide, which is when material moves as a coherent mass down a well-defined surface. There is flow, which is when material moves in a fluid-like manner. And creep, which is the slow downslope movement of surface material. The term rockfall is relatively self-explanatory. It means exactly what you might think. It is when a portion of bedrock detaches and free falls to the ground. This is the fastest moving type of mass wasting, and it often occurs as a result of frost wedging. Figure 5b shows a scar that was just recently left on September 27, 2017. The scar was left on El Capitan, a famous rock formation located at Yosemite National Park. A large portion of bedrock detached and free fell to the ground, resulting in the death of one tourist. Rock slides are the rapid downslope sliding of segments of bedrock. They often occur along a plane of weakness. In other words, an area is suddenly released and rock segments begin to slide downslope as a coherent mass. When this occurs, the rock segments will often trigger the releasal of other rock segments, which also begin to slide downslope. A rock avalanche is a particular type of rock slide in which air is trapped beneath the rock fragments. This reduces the friction between the rock fragments and helps to propel the rock fragments downslope. These can be particularly destructive. Slump refers to rotational slides that occurs along a curved surface. To help understand this concept, imagine a glass falling backwards when someone tries to pull a tablecloth out from underneath it. This same concept occurs in slumping, which is when the underlying sediment, is pulled out from the bottom. This results in the backwards tilt of blocks of regolith. The components of a slump contain a headwall scarp, which is a cliff that marks the initial line of fracture, a slump block, which are blocks of regolith that undergo the slumping, and the slump toe, which is the material that is washed out from underneath the slump blocks. Slump blocks can be identified by the backwards tilt of objects, such as trees or other objects. Flow is another type of mass wasting. Mud flows involve a flowing mass of water-saturated particles, silt-sized or smaller. Debris flow is very similar to a mud flow, with the difference being the debris flows contain fragments of rocks and other material mixed in. A lahar is a special type of flow. They occur at the site of a volcanic eruption. Snow and glaciers that surround volcanoes often melt at the time of eruption. This meltwater then mixes with unconsolidated ash and can form flows similar to that of a mud flow. An earth flow is a slower moving type of flow in which water is present but the soil is not at the point of saturation. They move as a wet tongue-shaped mass. So the material is not completely saturated and therefore does not move as quickly or as far as mud flows do. They instead slowly move downslope, and they often occur on grassy slopes, as seen in Figure 9a. Solifluction occurs in areas of permafrost, in which the soil is frozen solid. During months of thaw, the upper layers begin to soften and thaw out. However, the underlying layers remain solid and impermeable. When this happens, water is unable to correctly percolate through the layers. Therefore, it instead becomes saturated in the upper layers, and this oftentimes causes flow. This can be seen in Figure 9b. Creep does not refer to the well-known song by Radiohead, but instead the very slow downhill movement of soil and rock. Creep involves the largest amount of material being moved at once, and it typically involves entire hillsides. Creep can be identified by a forward tilt of tree trunks or other objects being acted upon. Notice in Figure A, the tilt can affect any objects along the slope, such as fence lines, gravestones, or telephone poles. In addition, it can even affect the underlying bedrock, which bends downslope as a result of creep. Figure 10b shows how tree trunks begin to lean forward under the influence of creep, while the actual tree itself continues to grow upwards. In this video, I introduced the four main types of mass wasting: fall, slide, flow, and creep. Each of these mass-wasting mechanisms have a major impact in the way that the Earth is shaped. And as you look around, you may notice some of these mass-wasting mechanisms that you may have never thought